Unit 5, Lesson 16, Representing Context with Equations. So for your warm-up, you are looking at the 4 different equations, and you are deciding whether the solution is positive or negative without solving the equation. So what it means by solution is it's wanting to know if the number that each variable represents is a positive or negative number. So negative 8.7 times 1.4 equals A. So would A be positive or negative? So A would be negative. Negative 8.7 times B equals 1.4. B would be negative. Negative 8.7 plus C equals negative 1.4. C would be positive. Negative 8.7 minus D equals negative 1.4. Okay, so D would be negative. So let's go look at this real quick. So negative times positive. So looking at this one, negative times positive gives you negative. So you have two numbers and the signs are different, therefore your answer would be negative. On the next one, we have negative 8.7 times B equals 1.14 or equals 1.4. So I know a negative times something has to give me a positive. So therefore I know it has to be a negative, because in order for my answer to be positive with multiplication, my two numbers have to have the same sign. On the third one, so negative 8.7 plus a number gives you negative 1.4. So if you think about on your number line, so negative 8.7 is somewhere down here, whereas negative 1.4 is somewhere down here. So if I'm at negative 8.7 and I'm adding, if I add a negative, I'm going to go to the left, but if I add a positive, I'm moving to the right. And I have to move to the right to get to negative 1.4. So C represents a positive number. On the fourth one, negative 8.7 minus a number equals negative 1.4. So again, I have to move to the right. Well, subtraction tells me to move to the left. So in order to move to the right with subtraction, I would have to subtract a negative. (16.2). So it says for each situation, you're going to find two equations that could represent the situation from the bank of equations. Some of these equations will not be used. You're going to explain what the variable represents in the situation, and then determine the value of the variable that would make the equation true. So number 1, between 6 a.m. and noon, the temperature rose 12 degrees Fahrenheit to 4 degrees Fahrenheit. So which two equations would fit this situation? So one equation would be V equals 4 plus negative 12. Then our second equation is V plus 12 equals 4. So what does the variable V represent in this situation? So V represents what? So V would represent my temperature at 6 a.m. Okay, and then you're supposed to determine the value of the variable. So what value for V would make these equations true? So 4 plus negative 12 would give me negative 8. So V equals negative 8 degrees. On number 2, it says at midnight the temperature was negative 6 degrees. By 4 a.m., the temperature had fallen to negative 16 degrees. So which two equations would fit this situation? Negative 6 plus V equals negative 16. And V equals negative 16 plus 6. So V represents my what? So that's my change in temperature. So what does V equal in order for these equations to be true? Would equal negative 10 degrees. So negative 6 plus negative 10 equals negative 16. Number 3, it says the temperature is 0 degrees at midnight and dropping 3 degrees per hour. The temperature is negative 6 degrees at a certain time. So let me zoom out so you can see the equations also. So which two equations would fit this situation? Next we have negative 3V equals negative 6. And V equals negative 1/3 times negative 6. So what does V represent for this situation? So it represents my number of hours after midnight that it took to reach negative 6 degrees. So the number of hours that it took to reach 6 degrees after midnight. So V would equal what for this equation to be true? So V would equal 2. So that tells me that it took 2 hours after midnight to go from 0 degrees to negative 6 degrees. So that certain time that it mentioned is 2 a.m. Number 4, the temperature is 0 degrees at midnight and it's dropping 3 degrees per hour. The temperature is 9 degrees at a certain time. So it's 0 degrees at midnight and drops 3 degrees per hour. The temperature is 9 degrees at a certain time. I'm going to scroll back up so you can see the equations. And I'll read it to you again. So 4 says the temperature is 0 degrees at midnight and dropping 3 degrees per hour. So the temperature is 9 degrees at a certain time. So what two equations would fit this situation? Okay, so our equations would be negative 3 times V equals 9, or V equals negative 1/3 times 9. So V represents my change in time. So this one's very similar to the last one. So change in time from midnight. When the temperature was 9 degrees. So V equals what for these equations to be true? V would equal -3, which tells me that my temperature dropped my temperature was changing at -3 degrees per hour, which means that temperature dropped 3 degrees per hour. And it took 3 hours to change to 9 degrees. Number 5, the temperature at 9 p.m. is 1/3 the temperature at midnight. So you might want to pause it on your equation so you can look at them. And I'll read it again. 5 says the temperature at 9 p.m. is 1/3 the temperature at midnight. So one equation would be -4 equals 1/3 times V, or -4 times 3 equals V. So for this problem, V represents what? Represents the temperature at midnight. So V equals what for these equations to be true? So V equals -12. So if we go back and look at number 1 and 2, what property would we use to solve these equations? So what property does number 1 and number 2 use? So it uses the additive inverse. So if you notice, the equation V plus 12 equals 4. Well, the additive inverse of adding +12 would be adding -12. So if I added -12 here, I have to do it to both sides. And this +12 plus -12 equals 0. V plus 0 is V. And then I have 4 plus -12. Same thing on number 2. So we had a -6 here. So the additive inverse would be +6. So -6 plus 6 would give me 0. And 0 plus V equals V. And since I added 6 on the left side, I also have to do it to the right side, which is where the second equation comes in at -16 plus 6. So for number 3, 4, and 5, it used which property? Hey, it used the multiplicative. Inverse. And remember, an additive inverse equaled 0, but a multiplicative inverse equals what number? 1. So here we had -3 times V equals -6. So the multiplicative inverse means I multiply by the inverse. So -3 times -1/3. And I must do that to both sides. So this -1/3 times -3 equals 1. And 1 times V is V. So then -6 times -1/3, which is what this is, and order does not matter with multiplication. Okay, so here you have finally completed this unit. So this was our last lesson of Unit 5. And then in my notes, remember multiplicative inverse equals 1 and your additive inverse equals 0. So on your summary, you choose a variable to write your equations that represents the story or the situation. And then you can use the multiplicative inverse or the additive inverse to solve for that variable. So if we have -3 plus x equals -17, we would solve the equation by adding 3 to each side. So -3 plus 3, well, I know that equals 0. So that leaves me with 0 plus x, which is x. And then -17 plus 3, which is -14. On the next example, our equation is -3/2 times h equals -6. So we would use the multiplicative inverse and multiply by -2/3. And again, you must do it to both sides. So -2/3 times -3/2 equals 1. And 1 times h is h. And then -6 times 2/3. Times -2/3, sorry. -6 times 2/3 would be +12/3. And 12/3 simplifies to +4.